All right, this is lesson 21, Scatterplots and Lines of Best Fit. So a scatterplot is a type of graph in which ordered pairs represent a set of data. The ordered pairs in a scatterplot represent the relationship between two quantities. There are three types of relationships known as correlations. A line of best fit is used to represent the data when possible. So you have positive correlations, so these are trending upwards. Negative correlations trend downwards, and then no correlation, they've got so many different points and they're all kind of over. There's really no line of best fit. The independent variable is typically graphed along the horizontal axis or x-axis, and the dependent variable is typically graphed along the vertical axis or the y-axis. While curves sometimes better represent the data in a scatter plot, only lines are used on keystones. Okay. So example 1, determine the type of correlation shown in the plot. So if I'm looking at this, it looks like from left to right, it's going upwards, so the correlation is positive. Creating a scatter plot. Since a scatter plot is a graph of ordered pairs, plot the ordered pairs on the coordinate plane. Scatter plots only work for data that consists of two parts. So example 2, create a scatter plot that represents the following data and then determine the type of correlation. The table below shows the number of people in attendance in thousands and the average temperature during a series of football games. So temperature versus attendance. Plot each set of values as an ordered pair. For example, when the temperature was 70 degrees, 37,000 people attended the game. Therefore, the ordered pair is 70, 37. Plotting all of the points creates the scatter plot below. Label the axes, and the correlation is positive. So here's my temperature. Here's my attendance. So this positive correlation tells me that the warmer it gets, the more people attend at the football games. Lines of best fit. A line or curve can be used to represent the data of a scatter plot. When a line is accurately calculated and drawn, it can represent all of the points on the plot and be used to predict values that are not shown on the graph. To find the equation of the line of best fit, follow these steps. Step 1, sketch the line of best fit. The line should divide the data into two regions where the points are about the same distance from the line. Step 2, choose 2 points on the line, not data points, and find the slope of the line. Step 3, use 1 point and the slope of the line to write an equation in point-slope form. The formula is provided on the reference sheet. So example 3, I draw a line of best fit for the scatter plot, then find the equation of the line of best fit. So here is my information. I want to draw a line that equally divides these points. They should be close to the line. It should be a straight line. So step 1 was sketch the line that best represents the data. This line should divide the data into 2 parts as best as possible. So looking at this, I've got a couple dots above, couple below. I got a couple that are really close, almost touching. I then choose 2 points on the line, not 2 points from the scatter plot. In this example, the line passes through 5, 5 and 30, 25. Find the slope of the line. So our slope is y2 minus y1 over x2 minus x1. So 25 minus 5 over 30 minus 5, which gives me 20 over 25 or 4/5. Since the slope is 4/5 and we have the point 30, 25, use the point slope form of a linear equation. So y minus y sub 1 equals m times x minus x sub 1. So y minus 25 equals 4/5 times x minus 30, which is my x value. The equation may have to be converted to slope, intercept, or standard form, depending on the question. It'll usually ask you specifically for what it wants. Predictions using the line of best fit. Once a line of best fit is known, it is possible to use the equation to predict data that is not available on the scatter plot. This can be done by entering the independent variable into the equation of the line of best fit and then calculating the value of the dependent variable. So this scatter plot in example 3 represents the number of times a student saw vocabulary words in books and the number of vocabulary words they identified correctly on a certain test. The test has a total of 50 questions. Predict the test score if a student saw the vocabulary word 50 times. Since we already know that the equation for the line of best fit is y minus 25 equals 4/5 times x minus 30, I solve the equation for y. So y minus 25, I'm going to distribute this 4/5 out. So I have 4/5 times 30 is 24. I'm going to add 25 to both sides. So y equals 4/5 x plus 1. Now I substituted in 50 for x and solve for y. So 4/5 times 50 minus 1 gives me 39. Therefore, if a student saw the vocabulary word 50 times, we would expect them to answer 39 of the words correctly. This does not mean that a student will answer 39 correctly. However, this is what we expect based off of the scatter plot and the line of best fit. All right, so go ahead and work on the exercises below.